So solutions that we are going to discuss for the assignment 2 or the tutorial 2. So only 3 questions are given on Newton-Raphson method. Okay, the first thing, Newton-Raphson method is a fast convergent method. It is a 2-digit convergence in one iteration generally. So that is a quadratic convergence is there, quadratic convergence rate is there, you can say. So right now question number 1 is find by Newton's method the real root of this equation, that is 3x equal to cos x plus 1. So in which mode we should solve this equation? Yes.
So 3x minus cos x minus 1 is equals to 0.
Yes, but which mode we should use for a calculator?
Radian mode, sir.
It's a radian mode. Okay, trigonometric term appeared, so should go with a radian mode. Now, in a question, I think this 0.6 is not given, but as he started with 0.6, so this is not good actually. Okay, why I'm saying, because how you come to know that you should use 0.6 only? Yes, I think this is a, what is the name of this student? Saransh, is it? So the number, yes, Sarash, is it? Saharsh.
Saharsh, sir.
Okay, Saharsh Rangappa. Yes, are you there? Saharsh.
He's in Div 2, sir.
Div 2. How I taken from a Div 2? It is written Div 1 here. Okay, this is written Div 1, so I taken him. Okay, so by my mistake. Okay, I will take it someone else. But remember, this is obviously not good because I will take here number 5. Okay, number instead of number 5 because I think I taken his assignment. Chirag, number 16. Number 16 is in Div 1, obviously. Okay, so this is from the number 15 and this is the correct way. This one you should follow. See, fx is taken as a 3x minus cos x minus 10. Why minus 10? It is a 1 is there, no? Why it is written 10? Chirag? Everyone is just completing, huh? You're not focusing. Focus there. Chirag, are you there?
Yes.
So why you taken this 10 here? So you should write what is a given. If you write this fx is wrong, so your entire thing will be the wrong. But later on you got 1 only. It is amazing here, huh? So you are copied from someone else then. Okay, definitely. So probably that fellow is written fx equal to 3x minus cos x minus 1 equal to 0, and you forgot it to write that equality sign here. That may happen. So f dash x, yes, we require derivative in Newton-Raphson. So derivative of 3x is 3, derivative of minus cos x is plus sin x. So that things are there. Now we started with a 0. F of 0 is checked as a minus 2, but f of 1 came as a positive. So that is 1.45. So as f of 0 and f of 1 have the opposite signs, so root is in the interval 0 to 1. So we can take x0 equal to 1 then. Okay, and if you are interested to check some middle values, you can calculate f of 0.5 also. And then you can say, depending on that, you can take 0.5 or 1 as a initial value. But don't take directly the 0.6 because how you come to know that 0.6 should be the initial approximation? It's not given in the question. So here the first iteration x equal n equal to 0, xn is taken as a 1. Okay, so this is the first iteration is taken as a 1, so this should be n actually, and this is f of x, f dash x, and this is x1. Then it is continued. Then you will observe first 0.62002 is appeared there. Second iteration, third iteration, only you require to calculate this f of xn and f dash of xn. So these functions are available there. And let me see what is the solution. The solution is 0.6071. 0.6071 is the answer. So yes, 0.6071 you got in the third iteration. So that is okay. Everything is correct. Everything is correct except that it is a 10 only. Otherwise, this answer is perfectly correct there. Any doubt, anyone here? Anyone have a doubt in the first question?
No, sir.
No. Come to the second question then. Second one is obtain the iterative formula for finding the square root of n. Hence find the root of 5 and root of 28. Okay, so there are two different questions. In the exam, you will get only one. So first thing you should write, you should derive this equation. This equation is the iteration formula for square root of n. Okay, and already we done this question in the class also. But this is one of the important type of the question. Number of times this type of questions are repeated in IMA exam. Remember, this question 2 type is very important. So we'll see the answers here. So let me see how Chirag completed. Yeah, fx. So first x is the root n. So x square minus n is a 0. So that should be fx, correct? F dash x is a 2x. So xn plus 1 is xn minus f of xn upon f dash of xn. So here it should be written f of xn upon f dash of xn there. So it is assumed say xn equal to xk. So xk plus 1. You should write xk plus 1 then. If everything you are shifted from n to k, so xk plus 1 is equal to xk minus xk square minus capital N upon 2xk. So everything is fine. So this is the iteration formula. You can keep this is iteration formula, or you can write this simplified iteration formula. Okay, the simplification goes by simply means just separate division there. I think it is xk square plus capital N, xk square plus capital N upon 2xk. So that is the iteration formula. So, and I'm not given this simplified here, but you will observe 2xk square minus xk square become xk square, and this minus minus become plus n. So correct, xk plus 1, I will write it, otherwise those who are not getting. So the iteration formula, you can keep this also, whatever written here. So you can keep this is the iteration formula, or when you simplified, the iteration formula should look like this: xk plus 1 is equal to xk square plus n upon 2xk. And so if someone is not happy with this also, you can take separate division, and your iteration formula you can write like this also: xk plus 1 is equal to xk by 2, xk by 2, and plus n upon 2xk. So this way. So choice is yours. You can write it any of the way. So this is your iteration formula, or this is your iteration formula, or this one. So that we can use for getting the square root of any number now. This is these numbers are not a perfect squares. If they are perfect square, their square root is easy to find out. Like square root of 16, you can write a 4 directly. But they are not perfect square, so we use a numerical method to find out their square roots here. So the way he completed, that's correct here. So this is the second question, and you got root 5 as 2.2361 by that formula. This formula is used again and again for writing this xk plus 1. Same thing for root 28. Root 28, this is the iteration. And generally, I already told you require roughly the 3 iterations in Newton-Raphson method, and that is the correct thing. So majority of the time you will get the answer in the third iteration only. So this is the 0th iteration, first and second. So third iteration we can say that way. Okay, so that about question 2. Any doubt in the question 2 here?
No, sir.
So the last question then, question number 3. Find the positive root by Newton-Raphson method, the real root of the equation x4 minus x equal to 10 correct to the 3 decimal places. So actually some word, there should be some correction in the question. Find the positive real root by Newton-Raphson method of the equation directly should be there. So obviously we are interested in the real root only. So this equation may have the complex root, but numerical methods used to find out only the real roots here. So that we have to find out. So we start with fx then. So this fx is x4 minus x minus 10 equal to 0. Now it is okay. F dash x is 4x cube minus 1. F of 0 negative, f of 1 negative, f of 2 is a positive. So the best part that we observed here, is that we have two consecutive integers where the function changes its sign. Hence, the root lies between the interval 1 and 2. Okay, root exists in the interval 1, 2. Now we can take x0 equal to 2. Here x0 is taken as a 2. That's okay, good. And the iteration started. And 1.8555 is the answer we got again in the third iteration. So that is the answer given. 1.856 is written. 8.555 is also okay, good, not a problem. So any doubt in question 3?
No, sir.